This video lecture is meant to explore the concept of limiting reactants. Sometimes they are referred to as limiting reagents. This is a tutorial and some practice problems. At the end of this video lecture, there will be 2 practice problems that you'll want to check in with your teacher to get credit for having watched this video. So the limiting reagent is in a chemical reaction, when you have 2 or more reactants, whichever one runs out first, that's the reactant that limits the reaction that can happen. So a simple example, you have 20 test tubes, you have 30 stoppers. You can only end up with 20 stoppered test tubes. So therefore the test tubes are your limiting reactant and the stoppers are what we call your excess reactant. Problem number 1. Okay, let's take it into the chemistry world here. Down here, problem number 1. Here's a nice limiting reagent problem we'll use for discussion. Consider this reaction where you have 2 aluminums and 3 iodine molecules to end up with 2 aluminum iodine molecules. The question is, or your task is to determine the limiting reagent. Translation, which reactant will run out first? Now in limiting reactant problems, you will always be given a quantity of all of your reactants. So in this case, you're told that you have 1.20 moles of aluminum, right? That's right there, and that you have 2.4 moles of iodine. Now notice that that's not necessarily in a 2:3 ratio as called for by the coefficients here, the 2 and the 3, but it's like a recipe. You might have 2 dozen eggs on hand, but the recipe only calls for 3 eggs. So the idea is we need to know how much of aluminum iodine can we make based on the quantities on hand. So we're going to use these mole quantities directly, and the way to figure out the limiting reactant is you start with those mole quantities. In this case, 1.2 moles or 1.20 moles of aluminum and 2.40 moles of iodine. Notice I'm not factoring in the coefficients yet, but I'm going to divide each one of these by whatever their coefficient is from the balanced equation. So the 1.20 moles of aluminum, I'm going to divide that by 2, the coefficient in front of the aluminum. I'm going to divide the 2.40 moles of iodine by the coefficient in front of the iodine from the balanced equation. So we see this when we actually do the math. And this is at the bottom of your worksheet, but you're going to get 0.60, okay, running out of room on my screen, and 2.40 divided by 3 is 0.80. So I'm going to scroll down to where you actually have this on your screen right here. So for the aluminum, this is how many moles we end up with, and this is the iodine moles. Whichever one of these 2 numbers is smaller, that represents the limiting reactant. Okay, so the aluminum quantity is going to run out first, and therefore we call it the limiting reactant. And the iodine, therefore, is the excess reactant. Okay, so there's a little explanation there of why it is, if you're looking for the math explanation. So we're just going to go ahead and take a look at a more difficult problem, and it's more difficult in problem number 2 only because I'm not giving you moles to start with, because you don't measure things in moles, you measure things in grams. So here we can see that you've got 15 grams of aluminum sulfide and 10 grams of water. Okay, so those are our 2 reactants. What we want to do is figure out who is the limiting reactant. Which reactant will run out first? So notice what we're going to do is we're going to take that 15 grams of aluminum sulfide, right? That's right here. And we're going to convert it to moles. Turns out the molar mass of aluminum sulfide is 150.3 grams. And when you do this molar conversion, you get 0.09980 moles of aluminum sulfide. If we do the same manipulation to the water quantity, 10.00 grams, turns out that that is 0.556 moles of water. Right? What we then do with those mole quantities is we are going to divide by the coefficient that came from the balanced equation. So there was a 1 in front of the aluminum sulfide, and there was a 6 in front of the water. So when we do this, we see that we get 0.0998 for aluminum sulfide, and we get 0.0927 for water. And so since 0.0927 is smaller, that allows us to decide that water will be the limiting reactant and that aluminum sulfide will be the excess reactant. All right, so your turn now, but a word of advice: keep a watch out for limiting reactant problems where the equation is unbalanced. If this is the case, you must balance the equation first before proceeding. So now there's two problems at the bottom here. Okay, this is what I will want you to work on and show me in class, right? So here we have a balanced equation, here we have an unbalanced equation. So make sure you're starting with a balanced equation. All right, that's it for the video lecture. We'll see you in the classroom.